Today's video is sponsored by Native Sons Goods, makers of the highest quality woven guitar, bag, and camera straps you'll ever see. Native Sons straps are handmade one at a time in the USA with unparalleled love and care. Click the link in the description to check out their new expanded lineup featuring all new 3-inch guitar straps. And remember, when you support my sponsor, you support this channel, and I sure appreciate it. Hey, how's it going, everybody? Brad the Guitologist here, and in this video we're going to take a look at this Musicman HD150. The story behind this thing is this belongs to Johnny Hiland, and this was given to him directly by Sterling Ball. The Musicman amplifiers in the mid to late 70s were partly also designed by Leo Fender, I believe the story goes, but I do know that this is a hybrid amplifiers, and it's not something that I've worked on before. I haven't serviced any Musicmans in the past, so this is going to be a learning experience for me, and should be pretty interesting for a video, so if that sounds like something you'd be interested in, stick around. You see there's no serial number for this. They may have taken the serial number off for some reason at the factory, but it definitely was removed. You can change the speaker impedance from 4 to 8 ohms. Uses a foot switch. I don't see a foot switch in here. I don't know if I'm going to be able to fully test that or not. Power on and off, and a ground switch on the back. So yeah, this should be interesting. I'm not really sure what the fault is yet on this thing. I just know he said it didn't work, so we'll have to figure out what the fault is, and yeah, we'll just kind of go from there. Okay, here we are with the back door off of this thing. You can see, once again, like I said, this is a hybrid amplifier, so you see there's no preamp tubes, but we do have 4 power tubes. So this has a solid state preamp and a all tube power amp. Let's see, over here we've got a chart, and yeah, this thing, obviously it takes 4 6L6 GCs, gives a chassis number, but not a whole lot more information. Musicman made in Anaheim, California. Huge power transformer there, real big. Nice big output transformer as well. These things usually have really nice clean tone, I do know that. I've played on a couple in the past, I've just never worked on any of them. You see right there, it kind of is designed similarly to Fender's in that it has the doghouse down there for the power capacitors. Nice big reverb tank. I'm guessing that's an Accutronics reverb tank. This thing has reverb, but it also has a phaser, which is an interesting thing to see on an amplifier like this. You don't see many amps with built-in phasers. So yeah, like I said, let's plug this into a speaker here, and yeah, we'll test it out and see what the fault is. But yeah, okay, we've got this thing hooked up to a 8 ohm speaker. We've got the load set to 8 ohms. I've got it plugged into the Variac. I think what I'm going to do is just kind of slowly dial it up, but before I do that, I'm going to check the fuse to make sure. I just want to make sure that fuse wasn't blown. It doesn't look blown to me, so I think we're okay with that. If a fuse is blown, then that's an indicator you've got a problem, and you don't really want to just fire something up, if you know, and test it like that. And like I said, due to the fact that I don't even know what the issue is, I just really want to fire it up with a little bit of juice on it and see what kind of readings we get here at the Variac mainly. Go ahead and bring it off of standby. And like I said, we'll just dial the juice up a little bit here. Okay, it's drawing some power, that's a good sign, because that means our power transformer at least is, you know, continuous on the primary, and there's no shorts. And it's drawing really low amperes as well, so 0.26 amps. And that's the thing about a hybrid amplifier too, you're going to draw a little bit less current overall than you would with you know, an all-tube amplifier. I'm going to stop right there at about 90 volts. I've got some reverb sound at the output, so I know I'm getting some output, so that's good. That's a good sign as well. And also that means the reverb probably works. Let's check channel 1 here. Whoa. Well, channel 1 seems to work fine, at least at the voltage I have the amp dialed up to right now, which is, like I said, 94 volts. It's not all the way up, but phaser seems to be working. man, I think this thing works. You know what, the thing about this is, this might have been one of those situations where where Johnny, he just sent this along because he wasn't sure about the status of it because it had been sitting around for so long. So he really wasn't sure whether it worked or not, and he wanted me to just kind of go through it and make sure everything was okay. So, you know, at the very least, I'm going to go ahead. I am going to open it up. We'll check the output tubes, make sure those are good. We'll check the power capacitors, of course, change those as necessary. We will also just check and see that, you know, just make sure everything looks okay on the inside. We'll clean the pots while we're in here. They seem okay, actually, but we'll go ahead and clean them anyway. We'll also clean the output tube sockets, clean the jacks, also clean the jacks on the reverb to make sure that those are okay. Right now, we're also, just as a note, we're also on the high power setting. This has a low power setting. I have not checked the schematic, so I'm not sure what the low power setting does as opposed to the high. Is it going to go into standby? Yeah, I guess it is. I really can't tell the difference between the high and low, so I don't know what that's for, really. Maybe that's some kind of pad for the front end, you know, so if you have really high output pickups versus like low output pickups, maybe it's something like that. Like I said, I'm not really sure without looking at the schematic, and we'll get a look at the schematic probably at some point here too. Now keep in mind, this is just my speaker here on the bench, so this is not going to sound great, really, but at least we'll get a chance to test it here and get an idea. Yeah, man, this thing sounds pretty damn good. And that's just a speaker out here on the desk. I know it's probably clipping in the clip here because this microphone really, you know, it's really for voice mainly. It's not going to handle, you know, a lot of loud stuff. But yeah, dude, that sounds really great. I don't know. I'd be interested to find out what this thing would sound like with a pedal board. I wonder if these would make good pedal platforms. I mean, you know, a lot of people are going to be turned off, let's face it, by the fact that it's a hybrid amplifier that has a solid-state preamp. But at the same time, I mean, if solid-state preamps, if they're well-designed and well-made, you know, they can be pretty reliable, and that might be something that's important to people if you're going on the road. So something like this might be a really great amplifier for that application. And also, like I said, it's this thing draws really low power considering that it's 4 output tubes. 4 6L6s, GCs at that. It's only consuming 36 watts overall of power, and that's about probably less than half of what it would normally consume just at idle. Well, let's see, that's with the thing off. Well, 49. Let's say 49 at idle. So that's still very low in comparison to what it would be at idle if it was an all-tube amplifier. So, you know, if power consumption is a big deal to you, that might also be a concern. But this thing sounds fantastic. There's not a thing wrong with it that I can tell. Like I said, I am going to go ahead and service it and give it a once-over. And then we'll give it a real proper test on a nice speaker cab. This thing has really nice feet on it as well. These are really nice rubber feet that just don't move. You could set that on a cabinet and be pretty assured that that wasn't going to go anywhere. It wasn't going to walk itself off the cabinet or anything if you rocked hard on it. Okay, before we go any further on this, I want to check what's under the doghouse here, and I've already got it off, as you can see. And we have a couple of very large Mallory capacitors here. They are 100 microfarad at 450 volts. Now, I don't stock that value, but I do stock 47 microfarad at 450 volts, so I can parallel a couple of those and make the value. And that's probably what I'll end up doing here rather than special ordering 100 microfarad, because it's, you know, it's not like it's going to matter. It's not going to show anyway. It'll be under the doghouse. So, but they don't look physically bad. I would say probably these could be left in here, and they would very likely operate for another, who knows how long, maybe 10, 20, 30 years if used consistently. But, you know, they are old. They are from 1983. So just, you know, for the sake of fully servicing this while we have it open, while we have it on the bench, I am going to go ahead and replace these. So some people might flip this thing over and replace every cap in this. That's electrolytic. That is not something I'm going to do here. And the reason is, most of the capacitors that are up here are all very low voltage, so they don't see very much voltage as it is. Like this one, for instance, this is 400 microfarad at 25 volts. It doesn't seem much. That one's 25 volts. This one's 150 at very low voltage as well. I think it's like 25 volts also. So those are all, even though those are you know, power capacitors for, you know, smoothing the power coming into this board, none of them appear to be physically leaky. None of them are displaying any kind of symptoms. The owner of the amp says that it's, you know, just kind of cutting out here and there. So it's, you know, it's just one of those things that's kind of intermittent. So what I'm guessing is this is probably a case of these two. These are actually power transistors that are on this rail. You can see they're on this heat sink. There's one here, and then there's a little pot right here. Transistors, not a lot of people really realize this, but transistors have to be biased as well. So this might be a case where these transistors here are not properly biased. I can check the bias on the output tubes also, but these output tubes and the way that this is all wired is really odd, and I'll show you what I mean. Let's take a look at the schematic. But actually, before we take a look at the schematic, let's just get a little closer look at these boards, and I'll show you some of the components that we're going to be kind of paying close attention to here. You see that we have a lot of this little IC right here. We have several of these on this main board. MC1458. What that is, that's a dual op amp. And I think I actually might even have a bunch of these on hand if it turns out any of these are bad, but I doubt they are. Like I said, it doesn't seem as if the amp is misbehaving, and if it is a problem, it will be an intermittent one, probably socket related. So we may end up popping a couple of these out of here, or maybe all of them, and cleaning the sockets, kind of reseating them to make sure that they're all getting good connections. But we have all of these dual op amps in here that are doing most of the work on the preamp. We have these here, and this is basically like an optocoupler, so you have like an LED in here, and you also have a resistor that is light sensitive, and you have a couple of these, and those will work in conjunction to create your phaser. I'm pretty certain. We could check that out on the schematic as well, but this is the area where your phaser is located, and this is probably phaser related. As you can see, it kind of is tied into this circuit as well, so that probably adjusts your phaser. So if you're having any issues with that, that's most likely where you would adjust that. I presume it could also be reverb related too, that part right there, but I haven't quite, I haven't studied the schematic in detail yet. But you can see a couple more of those 1458 dual op amps. You can see a couple more up this way. So several of those in here. There's 1, 2, 3, 4, 5, 6, 7 on the main board. And there's another one right over here. So that makes a total of 8. And then you've got these two, which are JE 1692s. We'll take a look at what those are here in a bit. Motorola. And once again, I already know what they are. They're actually power transistors. So normally you might find those in a probably a kind of a low wattage, little amp or something like that for the power output. But in this case, they're outputting into the final amplifier stage. And then once again, you have this little adjustment right here, which I presume is to adjust the bias on those. We've got a couple of little transistors over here as well. We've got 4 of these, in fact. There's 1, 2 right there. I don't see any numbers on those, but luckily the schematic is fairly thorough, and they tell us exactly what those are. But once again, I don't think we have any kind of issues with those. So probably this is going to be a situation where I do a lot of cleaning on the pots, cleaning on the jacks, clean the tube sockets on the output just for the heck of it, because I have it open. Change the main power capacitors. I'll probably leave these capacitors alone. Once again, I could change all of those. I could shotgun them. But these are very low voltage. They are nice American capacitors, and I don't think that these are going to be wearing out anytime soon. This amp could be somewhat historically significant to the Musicman company, because this is right around the time that Ernie Ball took over Musicman, and this exact amp was given by Sterling Ball to Johnny Hiland, and it is it's 100% original as it now sits. And the only thing I'm really going to change at this point would be the power capacitors, which is a given. That's something that's easy to explain away. Now I could go in here and take the ground switch out. I could modernize that circuit if I wanted to, and the power and everything, to get rid of the ground capacitor right here, which essentially also is called the death capacitor. But it is not even in the circuit when it's in the middle anyway. So I mean, that's a decision. That might offer you some flexibility if you're in a live situation and the wiring isn't great, and it's like you find you have some hum and you flip it one way or the other, and it might take care of some hum issues that you have in certain situations, maybe under certain lights or something, if you're in a live situation, which could be possibly useful to have. But most likely, I mean, if you're in a place with good wiring and a good ground, it's not going to matter anyway, no matter where you put this. So if you have bad ground in a place, you probably don't want to be playing there, to be quite honest. So it's kind of a throwback. It's something that really isn't going to be used, by anybody in any kind of professional setting, most likely. and it does pose somewhat of an outside chance of a danger, like if you have it in one way or the other, and this shorts to ground, maybe you could have experience some issues with that, possibly, but it is very remote it ever being a problem. So most likely, I realize the danger, don't get me wrong. I realize that there's an outside chance of a danger there, but also I do also realize that this amp, is something that is very clean. It's very original as it sits, and given the history of it, it was given by Sterling Ball to someone who I consider one of the great guitar players of our time. It can probably stay as it is, and I'll just advise him to leave it in the middle unless he has issues. So that should thwart any kind of safety concerns just by leaving that in the middle. We're going to take a look at the schematic and see what we can determine about how these should be set. We might also have to look at the data sheet for these transistors here, because I believe these to be at fault. If he's experiencing issues with the amp heating up and as it heats up over time and it gets maybe too hot and it just kind of drops out, these would be my prime suspects right here, and adjusting that is probably going to take care of it. But we need to find out what the specs are on this so that we can do some measurements and see how far off we might be. It could, it's an outside remote chance there could be a bad connection or something on this board underneath, so if we have to, we'll pull this board. But right now the game plan is, let's look at the schematic and see what we can ascertain about what kind of voltages we should be seeing right here. Okay, so let's start looking at this schematic here. As you can see here, most of the preamp, or well, all of the preamp is amplified with these little ICs, these 1458s, and this right here is a gain stage, and this is one half of one of those 1458 little chips, those little ICs. There are two of these in each one of those envelopes, so you've got one here and then another one here, and then this will be one, and then the same down here on this channel. But the thing I really want to draw your attention to is over here, this section. This is the section right before the output, and you can see there are two little transistors here, the two N6488s, this one here and this one here. Very interesting thing about this circuit is that this is the phase inverter, okay? So you've got the phase, which actually is inverted back here. Then you have a driver on this side that drives signal into the cathode of these two output tubes. You can see one leg comes over here to this cathode, the other leg comes over to this tube cathode on the output for this side, and the same thing over here on this other side. So the phase is actually inverted right here. You can see the signal comes in, and then when it comes off of this IC, you've got it coming down here into the input on this side. So this takes care of the phase reversal for this half down here. So this actually in effect is the phase inverter right here, this IC, and that is probably that one 1458 that is on that output board. But then you've got these two, and these are actually drivers into the output. And again, you've got one down here that's driving signal into the cathode, which is interesting and weird. And then you've got another one up here which is driving signal into the cathode. So what happens here, you have basically a flat signal that's coming in. You'll have AC that's going up and down, so the voltage will vary. And then you're going to have a corresponding voltage on the plates of each one of these tubes. As that tube amplifies the signal. Usually, the way this works is you input the signal into the grid, and the grid basically keeps the voltage coming from the cathode. It will actually turn it on and off. So the grid actually controls, that's why they call it a control grid, because the control grid will turn the tube on and off. It'll basically let more or less voltage through depending on what signal is applied to that grid. And that grid is usually the signal from your guitar is going into that grid, controlling things. However, this is different. The fluctuations in signal are actually being done at the cathode. So if we look at the grid, We come over here, it goes through an R74 resistor, and then to this point, if we follow this one down, it comes down to here, and these are also tied to the grids over here. Then we have this point right here tied in. So if we follow it down, we have plus 22 volts DC. So this is actually a consistent voltage being applied right there on all of these grids. So it's a positive grid bias. And then the actual signal is being controlled at the cathode. So this is really different than what we're used to. And this, I am assuming that they've done something like this because they have found that it keeps the tone cleaner, would be my guess, on the output. So, you know, that's just a guess. You know, obviously you'd have to set up an experiment where you tried it both ways, you know, with the same setup, where you came off of the phase inverter, and instead of going into these 2N6488s on each side, where you actually just went directly into the grid of one of the output tubes and then controlled it in the usual way. And then you could test that and see how clean the tone was and how much headroom you had and so forth. And then, you know, you could have it A/B with this version, which I would say that's why they did this. You know, usually that's usually Leo Fender's MO. If he was always kind of searching for clean headroom in his amplifiers, and I would say that's why this is designed this way. Probably because you know, he discovered that this was a very clean way of doing this. Leo Fender, of course, was he was kind of a consultant very early on in the creation of Musicman amplifiers. He couldn't really officially be part of Musicman until his non-compete agreement with Fender ended. But once it did end, he was then officially, you know, on the board of Musicman. I think he was doing a lot of their designs, possibly including this one. So that would explain, I think, why this is this way. And really, you know, I mean, when you look at this, these output tubes, if they're doing this to keep this clean, then it kind of begs the question, why didn't they just make the entire amp solid state? Because they got it solid state all the way up to this point. Why not just go ahead and make the output solid state if they were going to try to keep these tubes from clipping anyway, you know, using this odd way of doing it? So I would say it probably has possibly something to do with marketing. You know, a lot of players at the time, they were really skeptical of solid-state amplifiers, and usually for good reason, because not a lot of the solid-state amplifiers at this time sounded very good. But yeah, very interesting amplifier, and I think what we're going to have to do, we're going to have to come in here, and you see this TR1 right here, this trimmer pot. This is post-phase inverter on this trimmer pot. And I would say this is what this is doing is it's regulating the amount, because this is a path to ground here, so I would say this is regulating the amount of signal that's getting to these transistors here. So if these are being overdriven or overloaded, they might have a tendency to shut off. And if they are not being driven hard enough, they probably will have a tendency to be somewhat brittle on the tone. So you kind of have to get that balance right, and I don't know, it doesn't really give me any kind of, you know, readings here like to go by. Okay, let's get a look at the data sheet for this particular transistor. This is a complementary silicon plastic power transistor. Like I said, it's a power transistor, which is just odd, but they're driving the signal, like I said, directly into the cathode of the output tubes. But you can see here it has the numbers for the pins, pin 1, 2, and 3. Pin 1 is the base, pin 2 and 4 are the collector, the 4 being the heatsink attachment, and of course 3 being the emitter. So we should be able to you know, hook onto the emitter, let's see, collector to emitter, and also collector to base, and we can make sure that these voltages are not exceeded. So I want to test these voltages. I want to test the emitter to base, make sure it doesn't exceed 5 volts. I want to check the collector to base, make sure it does not exceed, what do I have here, 88, so it'll be 90 volts, right? Which it shouldn't even come close to that in this application, I don't think. But then we have 6488. We have 80 volts for the collector to emitter. So I want to measure each one of these and make sure that these aren't being exceeded. All right, so there we are with the new capacitors. Those are installed and ready to go. So I'll put the doghouse back on this thing, and we will check those output driver transistors now. Okay, I've gone ahead and lifted this board just to make sure there are no, faulty connections or anything underneath the board, and it does not appear that there are any faulty connections. So but if you need to replace this board ever, that's the number of the board, DB4. Collector to base, it's 90 volts. 90 volts max. And we have 54.88 volts. 65 volts. That's between the collector and base. 66 volts between the collector and the base. Now I'm guessing that's going to change when you put the signal in. And I want to see if that actually changes when I adjust the pot. I'm going to adjust it somewhat. I'll keep an eye on the voltage over here. I don't know if you even see it. There you go, you can see it right there, 66.0 volts. And we'll see if that changes at all. And it does change. So you basically can turn these on and off. Okay, you see that voltage is going from 52, 53, 54, 55. So I'm going to put it back about where it was. But see, I can turn it all the way off by driving that voltage higher. I'm actually going to dial it this way just a hair. Okay. And I think that's getting us further away from the cutoff point for this thing. So we were over this way a little bit, so we were at a little bit of a higher voltage. So I've dialed it a little bit further away from that. So during its cycle, it should be further away altogether. So maybe that will prevent it from going into having the problem of cutting off or shutting down once it's been too hot. The other measurement I want to get is I want to find the bias voltage that will be coming off the grids of these power tubes. So that should be about 22 volts. The other quite shocking thing I see on this schematic is that there should be 700 volts going into the output transformer. That's a very high voltage. R87 or diode number 15. So where are those? See, that's the problem. They're not labeled on here. Yeah, it's too bad they have everything labeled on the schematic very well, but nothing is labeled on this. So that makes it a bit more difficult. Okay, well, let's see. Into the grid, we've got a resistor. Oh, okay, I'll just go on the other side of that resistor. Okay, so right there we should have about 22 volts. Let's bring it off standby. And we do have 21 right there, 21.5 volts or about. And then we'll have another pair over here, so we'll check right here. And what are we looking at there? Same, about the same right there. So we're good there. I'm kind of curious as to what these plates are actually at. So let's check that. 707 volts. God, that's a lot of voltage. I'm pretty confident that we've set this where it needs to be. I've moved this. I actually reduced the idle voltage. Yeah, between the base and the collector, I actually reduced the idle voltage a little bit, so we're well below the maximum value for that. Alright, so this thing is actually checking out really well. All the voltages that are printed on the schematic are pretty much dead on. I've got these two well within spec of what they call for on the data sheet. So barring some, some kind of other issue that might be intermittent, this thing I am pretty confident is ready to go. Okay, so this is the point in the video where I would normally strap on a guitar and show you guys a demonstration of the sound, but I'm pretty sure you guys are probably about sick of hearing me play anyway, and besides, I got a better idea. I like that last little lick.
Oh, I've been through a lot of changes in my career in gear.
Right.
And really most of it was not by choice. In my Musicman days, Sterling Ball had given me this amp. And I played this amp on the road and in town and on sessions and stuff for years, since probably 2010 or 11, I reckon.
Mm-hmm.
And I played it all the way out. I just joined up with Kiesel in 2018. So, and I also, tried to find the right amp home as well. And of course went through companies that lasted a short while and went out of business. And so I went right back to the old Musicman.
Yeah.
But then again, these amps are iconic, man. I mean, this is what Eric Clapton used on Lay Down Sally and, the Slow Hand album and of course albums after that, I'm sure, until into the 80s when he changed, but went back to Fenders, I guess. But these old Musicmans are just, they're still iconic amps to this day. And of course, Albert Lee played them, for years as well.
Yeah, you said the second channel had gone down on you, right?
Yeah,
nice.
Man. This amp literally stopped working on me. It's really bothered me when this amp went out. And being that, look, I'm not going to say anything negative about Musicman. It just didn't work out, just like anything else in the music business. If it doesn't work, it doesn't work.
Right.
But Sterling Ball, was an absolute sweetheart to me, and I love the man to death. I always will. But this is something that is a piece of Johnny Highland history for myself to hang on to remember the Musicman days. And Sterling gave me this as a gift from his personal collection, as far as I know.
Well, like I told you, this is also a piece of Musicman history because this is, I believe, the first run of amps that Ernie Ball must have made with Musicman when they bought that company.
I'm sure.
Because they merged around 83, 84, and this is like right there on that line. And I would say this is probably something that Sterling, was one of the first amps when he came onto that company. He got that for his personal amp, and that's the one he probably pulled off the line that he said, this isn't going to be mine.
Like I said, man, it's just one of my prized possessions. I'm not a guy that hoards gear. My amp collection's pretty small.
Mm-hmm.
Now I'm with Fat Jimmy amps. I have 2 of those. I've got 2 Reeve Space Cowboy 100 watts, and I've got 3 little other old Musicmans. Well, actually, I take that back. I have 5 Musicman amps in total. Because really, I love these old Musicmans because I was a big Albert Lee fan too. And so, you know, Danny Gatton and Albert Lee, as far as your country guys, man, I mean, they're both icons.
Right.
And so it was really hard to find Tweed twins like Danny played for a lot of years. So, but I could, you know, since moving to Nashville, I could find, hey, I could put my hands on these, the little ones, you know, the 112s, and go play clubs with them.
Yeah.
But when Sterling hooked me up with this one, man, it's got that iconic tone. But it did. It went down on me on a show, and I don't know. It freaked me out, man. It was like, gosh, you know, it was, and it seemed like the more amp guys I'd ask about it, oh, I don't fix Musicmans, dude. They're hard to get parts for and stuff like that. It sat at my house, you know, broke down for a long time, and I just thought, I don't know what I'm going to do. But like I said, man, this irregardless of what happened with me and Musicman, Sterling is, you know, he'll always have a place in my heart, man. He was good to me.
Yeah.
And I love the man to pieces, and this amp is always going to stay with me. And in fact, this little studio we're in right now is called the Fresh Factory. It's where I actually cut my gospel album, and it's where I'm cutting my new Christmas album right now, currently.
Cool.
And Blake Padilla is a dear friend of mine. We're like brothers, man. We produce together. He engineers. He's a great background vocalist, amazing keyboard player, B3 player. And of course, like Danny Gatton did the record Relentless with Joey DeFrancesco, we're doing our Christmas record together with B3 and guitar. So,
oh, sweet.
So we're having a blast doing this record. But at the same time, I said, you know what, brother? I don't want to see this amp sit at home and not be used. And I said, all the buddies we have that come over here and record are all friends of mine. No one's going to abuse anything. Mm-hmm. So I said, man, where Brad has really got this bad girl up and running again. I said, you know, when boys come in, if they need an amp, it'll be here. Yeah. And when I come into town, I'll have an amp here.
You said the phaser also never worked for you?
No, it didn't.
Phaser never worked. Okay, well it works now. Let's check out the phaser.
Well, sure. Let me cut my compressor off just so we can hear the amp.
So that it gets
Yeah.
Oh, you know what that reminds me of? It reminds me of like the old Willie Nelson, like 70s
well, it kind of reminds me of the old Whalen stuff.
Yeah. Yeah, exactly. Yeah, totally. That's what it reminds me of.
Yeah.
Too. And you know what I found out about this, and I kind of teased you with this a little bit earlier. This speed control, okay, it's the second one from the end. You got a master and you got a speed control on for the phaser. Yeah. With this speed control, you can actually pull out.
Really?
Okay, and you know what it does?
What?
It shuts the oscillation off, and you can set it exactly where you want it in the swoop.
Oh, yeah, no way!
Check. You know what that allows you to do? Like if you're rocking this thing up, for instance, crank your guitar. Or something, you know what I'm saying?
Well, you know, man, it's funny when you had that really creamy chorus. It kind of reminds me of like the old kind of Christopher Cross stuff, you know that, or like the old Kenny Loggins stuff.
Oh, what?
actually set where
Yeah.
you want the oscillation to be.
Yeah, pull your speed control out, and then you can set it, and so it disengages the oscillation. You know,
Right.
it won't go, it won't do that.
Wow.
I couldn't believe it when I figured that out. I was like, holy shit, man.
Dude, I never had any idea.
You didn't even know that was there, did you?
You know, I'll be honest too, man. An amp like this too, I was almost a little bit scared of it.
Yeah.
And I say that with all reverence to music, man, because truly, man, these amps are so iconic that I literally was like, I'm gonna find the clean tone that works for me, run my pedal board, get the perfect amount of reverb from it, and leave it alone.
Right.
So I didn't sit and really just tweak and pull knobs, and because you know, man, we have all played those old amps where you start grabbing the knob and it just falls off. You're like, oh, shit, you know. So no, man, that is just awesome, dude. So which knob was it?
It's the
Second
speed
one up?
control, the second one over, yeah.
Wow, man.
Yeah. And if
Look
you
at
want it to
that.
oscillate, you know, it'll go right back to Go right back to
It just has that real spanky, just.
It does, doesn't it?
Now I'm not running anything now, man. I mean, my delay's off, the reverb's off.
So we're straight into the
So
amp.
we're straight into the
Yeah.
amp now.
Oh, I know. It's like, it's sick. I love it.
Oh, man.
I love it.
I mean, it's just chewy tone, man.
I know it.
But, you know, this amp means the world to me because Sterling gave it to me, and now, brother, you've added to the history of it.
Well, Johnny, are you hungry?
I am hungry, my brother.
Well, let's go get something to eat, man. Listen, everybody, I appreciate y'all hanging out for so long. And Johnny Hiland,
Oh, hey, man.
thank you, man. I can't
Thank you,
enough,
buddy.
man.
I'll tell you what,
Thank
what
you
a
so
pleasure,
much.
man. And God bless you out there watching. If you're a guitar player, keep on picking and always have fun with it.